Alright, so just going to record Friday, September 25th lecture notes. So if you happen to miss or just wanted to hear my voice magically deliver the world of chemistry again, this is for you. Alright? So what we did today is we started talking about differentiating an average from a weighted average. Alright? And we'll talk about what that difference is as we go through, but what I need you to have in front of you first, your periodic table that I printed off and gave to you guys that you guys need to have on hand, easy to get to all the time. And you're also going to want a calculator because there is some calculating that goes along with our averages and weighted averages. Alright? And the weighted average is really where we're going to focus our time. You guys should already know how to do averages. Alright? So, we're going to focus on carbon again. Because that's that example we're familiar with from ChemQuest 6. Alright? So carbon has three isotopes that exist in nature. We got carbon 12, carbon 13, and carbon 14. And as a reminder, just so you guys remember, carbon 12, carbon 13, and carbon 14, they're all going to have 6 protons, because all carbon has 6 protons. If it doesn't have 6 protons, it's not carbon, right? And so those different masses are made up for by different numbers of neutrons, right? So carbon 12 would have 6 neutrons, 13 would have 7 neutrons, 14 would have 8 neutrons, right? So that's all that stuff we learned back in the last ChemQuest, all right? Now, if I was just to do a traditional average, find the average of those three masses, carbon 12, 13, and 14, you should be able to spot pretty quick that the average of those three masses is 13, all right? Average between 12, 13, and 14, the average is 13. And you can do that on your calculator, 12 plus 13 plus 14, divided by 3, 13. Okay? Now, if you go to carbon on your periodic table, right, what is the average mass according to your table? So you should have that little C with the 6 on top, and then it will say 12.01 underneath it. Now, that 12.01 is supposed to be my average mass, but that does not match that 13, right? So the question to think about is, what is causing that difference? Why is the average mass from the periodic table different from the average you calculated? So we calculated 13, the table says 12.01. What's that difference, and how do we account for that? Okay? So, what you have to understand is the values are different because not all isotopes have the same abundance. Alright, and abundance is how common. Okay? So, since the average mass of carbon is 12.01 AMU, and we're not going to argue with that, that's been experimentally determined by really, really smart people, right? I'm not going to try to tell them they're wrong. So let's assume that value is correct, alright? Which isotope would you guess is most abundant, right? So we got 12, 13, and 14 to choose from. My average is close to 12. So I would probably use my logic and guess that carbon 12 is the most common isotope. And in fact, it looks like it's by far the most common isotope because the average is really close to 12. Alright? So what we need to consider then is when we say a weighted average. The weighted average accounts for the various isotopes and their relative abundance. So it kind of takes both of those things and factors them into that single average number, okay? So, how do we do that? How do we calculate a weighted average? So one thing I want you to consider first is, let's say your chemistry grade, right, is determined 20% daily work, right, and 80% tests, right? So, if you have, let's say you get 100% in that daily work. Nice job, by the way. I appreciate that, and your grade probably does too. But let's say on a test you're averaging 70%. Alright? Now, traditional average in this case would only consider that 100 and that 70. Alright? So my average between 170 would be 85%. Okay? Now, if I was to use my weighting, I would have to say that my 70% this category, 70%, is actually 4 times more valuable than that 100% in the 20%, right? So my average in that case would not come out to 85%. It would actually come out closer to that 70%. It wouldn't just be that midpoint. And so we'll talk about how you can actually calculate that here in a little bit, okay? So how do we then go by the process of calculating weighted averages? So I'm going to show you some steps here, all right? And then after that, I will go through an example with you guys just to kind of explain how that works. All right, so identify all the values. So typically for us, that's going to be the isotopes. And we'll usually use their mass number, okay? So the values we'll be averaging is typically going to be the mass of the isotopes. 2, make sure you know their percent abundance. All right, so nice thing is steps 1 and 2, they are given. They'll usually be in the actual question itself, or I might put a little table and have you refer to that table or something like that. But 1 and 2, those values, right, so the mass of the isotopes and their percent abundance will be given to you in the question, right? So really, you just need to recognize those when you see them. 3 is where you start doing some work, all right? So their percent abundance, that's a percentage, right? So like, say, carbon 12 is 98% of the carbon atom, so its abundance would be 98%, all right? So we got to convert those percentages into decimal form, all right? Now, I said this in class, I'm just going to say this now, right? This little step 3 right here is the one that's most commonly screwed up, and it's the easiest thing. I don't know why. I can't for the life of me figure out why this is forgotten or screwed up so often, but it is, okay? So all we have to do is we take the percent, right? Convert it to decimal form. We move the decimal 2 places to the left, all right? So if I had a 98.45% abundance, right? I'm going to move that 2 places. So my decimal form would be 0.9845, right? And you all know how to do that. And why we continue to mix that up, I don't know. But we're going to try to get that wrinkle out of our system. All right. Next step is we're going to multiply each value. Remember, our value is probably going to be our mass. So value will be mass by its decimal abundance, right? So we've converted the percent to decimal. We know the mass of our various isotopes. We take its percent, turn it to a decimal, and we are going to multiply those 2 values. All right, and then last, so this is again where people go wrong. Last thing we do is add, right? So I've taken my mass value, multiply it by my decimal abundance, and I just add all those different numbers up. So no dividing, okay? No dividing necessary with weighted averages. No dividing. So with a traditional average, you add and divide. With a weighted average, you multiply, then add. No dividing. All right. So we're going to do a practice. So here's our 3 isotopes, carbon 12, carbon 13, and carbon 14. And it says right here carbon 14 is negligible because it's less than even a fraction of a percent, right? Too small to really make a difference at the level which we're going to do. So when something is negligible, that means we get to disregard it. So we're going to only use carbon 12 and carbon 13, okay? So step 1, if you recall, identify all the values we'll be averaging, 12 and 13, okay? Step 2, make sure you know their percent abundance. Remember, step 1 and 2 are given, 98.93, 1.07. Okay. Step 3, convert percentages into decimal form, which means I move the decimal 2 places to the left. So here's my 98.93. So my new decimal form for carbon 12 will be 0.9893, and 1.07 will become 0.0107. All right. So I've done step 1, identified my values. Step 2, found their percent abundance. Step 3, converted percents to decimals. All right. Now, step 4, I'm going to multiply each value by its decimal abundance. All right. So I'm going to take 12 times 0.9893. I'm going to say equals. All right, so I enter that on my calculator. That's why we need that calculator, and I get 11.8716, right? And I'm not really going to focus on my sig figs for these weighted averages. The reasons for that are actually numerous. So I'm just going to report all those decimals for the moment, okay? Then I'm going to go 13 by 0.0107. All right, so 13 by 0.0107, and I get 0.1391. Okay, so now I've done my step 4, which was to multiply each value by its decimal abundance. So step 4, check. 3, 2, 1, check. So now I'm just going to add. No dividing. I'm going to add. So I'm going to take 11.8716 and 0.1391. I'm just going to add those two values together. So I go back to my calculator. And what I get is 12.0107 when I add those together. And that would be AMU, by the way, for atomic mass units. All right? Now, the question is, we could always check our work with this. Does this number match pretty closely the number we saw on the periodic table? And if you go back and look, right, that number was 12.01, right? Those numbers match beautifully. And in fact, I set, so online where I printed off the periodic table, I set it to round to 2 decimal places. So if I were to round this to 2 decimal places, 12.01, 12.01. Hey, the math works. I love it when that happens. All right, so that's what we did today. Then we have the rest of the period to work through critical thinking questions. All right, I'd like to have that done Monday. By the way, test is Thursday. This is the last lesson from this unit, so you have between Friday and Thursday to kind of master all this material. So ChemQuest 7, we'll finish that Monday. You guys will be getting all your review materials then too. All right.